Good afternoon to all of you. Myself, Professor EMI-LPF from SND College of Engineering and Research Center, Yavla. So today we are in previous lecture, in previous video, we already studied that the dynamometer type wattmeter construction, working principle, advantages and disadvantages of dynamometer type wattmeter. Now in today's video or today's lecture, we are discussing about the two topics, that is low power factor wattmeter and three-phase wattmeter. The low power factor wattmeter, the instrument that measures the low value of power factor accurately, is known as the low power factor wattmeter. Means to measure the power under the low power factor, that is for inductive load, as well as for capacitive load. The low power factor meter is used for measuring the power of highly inductive circuit. It is also used in resistive circuit, which is a power factor range from 0 to 0.5 to 1. 0.5 to 1. What is the need of low power factor wattmeter? The ordinary wattmeter used for measuring the low power factor gives the inaccurate result. This is because of two reasons. Suppose we use the general wattmeter, that is unity power factor wattmeter, for the measuring of low power factor, means for inductive load, then we can use the result inaccurately because of two reasons. The first is, in low power factor meter, the magnitude of reflective torque on moving coil is small even after the full excitation of the pressure and current flow. Means in a LPF type of wattmeter, the deflecting torque, that is the deflecting torque which is required to move the pointer from 0 to maximum value, this is very small as compared to the UPF meter. This error occurs in the reading because of the pressure coil inductance. This error occurs in the reading because of the pressure coil inductance. Some additional features are added on the ordinary wattmeter so that the meter can be measured the power of the low power factor circuit. Means suppose the UPF meter, means the normal wattmeter, that there is some modification required to make the low power factor wattmeter. The low power factor wattmeter in an ordinary electrodynamometer type wattmeter is used for measurement of power in low power factor circuit, that is power factor which is less than 0.5. Then the measurement would be difficult and inaccurate because of the deflecting torque exerted on the moving system will be very small, and error introduced due to the pressure coil inductance. Due to the pressure coil inductance, means which is large as LPF meter. Means suppose the pressure coil inductance is already higher and the load is inductive load, then the inductance should be high. Then due to this, the torque, deflecting torque produces will be very less. In a LPF wattmeter, the special features are introduced in a general electrodynamometer type wattmeter circuit to make it suitable for use in LPF circuit as under. First, which modification we have required, that is first, pressure coil current. We adjust the pressure coil current. The pressure coil circuit is designed to have a low value of resistance so that the current through the pressure coil is increased to provide an increased operating torque. Means for making the low power factor wattmeter, the pressure coil resistance the value of pressure coil resistance should be uh, which will be decreases. That is, a low value of resistance should be required. Due to that, the high value of current will be passing through the pressure coil, and due to this, increase the deflecting torque. That is, operating torque should be increased. Second modification is compensation for pressure coil current. Suppose pressure coil current is increases, this will be compensated by using another current. On account of low power factor, the power is small and the current is high. Because of the power is constant, then I into cos pi ratio is product of I into cos pi is always constant. That's why if the power factor is decreases, then the current flow to that circuit should be increases. In this context, there are two possible connections of the potential coil of a wattmeter shown in figure. The connection A can be used since owing to the high load current, there will be a high power loss in the current coil, and hence the wattmeter will have a large error. If the connection B is used, then the power loss in the pressure coil circuit is also included in the meter reading. Suppose this type of connection is used, this like electrodynamometer type wattmeter, then due to this, at low power factor, the power measurement, the error should be occur in the measurement of power. Thus, it is necessary to compensate for the pressure coil current in a low power factor wattmeter. For this, a compensating coil is used in the instrument to compensate for the power loss in the pressure coil circuit. Means the compensation winding which is used to reduce the pressure coil inductor. The pressure compensation for pressure coil inductor at low power factor, the error caused by the pressure coil inductor is very high. Means at the low power factor, the low power factor should be less for the inductive load. That's why the inductance of the coil should be increased. Here, these are to be compensated by connecting the capacitor across a portion of the series resistor in the pressure coil circuit. Means this is the one. This is the diagram. Means this is a series resistor. The capacitor which is connected across the pressure coil resistance. And second, realizing a small control torque. Low power factor wattmeter are designed to have a very small controlling torque so that they can provide full scale deflection for power factor values as low as 10%. Thus, the complete circuit of a low power factor wattmeter is shown in figure. This is a complete connection of the low power factor wattmeter. This is a current coil. This is a compensating coil which is connected over the current coil. And the capacitor which is connected across the series resistance of the pressure coil. This is your low power factor wattmeter which is used to measure the power under the inductive load or capacitive load, that is at low power factor condition. Next topic is polyphase wattmeter. You know that in three-phase circuit, in three-phase circuit, there are three phases. In polyphase circuit, there are three phases R, Y, and B. For measurement of power in a three-phase circuit, we require the three separate wattmeters. Three separate wattmeters in each phase. But this is the complicated circuit. This is the complicated circuit, and the connection should be complicated. That's why the new concept is arises, that is polyphase wattmeter. It is the connection of the polyphase wattmeter is like similar to the two wattmeter method. The power measurement, three-phase power measurement by using three wattmeter method. That is in that polyphase wattmeter, there are two pressure coils and two current coils. Current coil A, current coil B, voltage coil or pressure coil of A and pressure coil of B or voltage coil of B. Means there are two voltage coil and there are two current coils. Then the point M, L, V, C. B, C, this is your B and this is your C, and the connection of point of wattmeter L, L and C will be short, and V will be connected to each other, and this will be connected to the third phase. The current coil of the two current coils are connected in series with the two low phases. Suppose R and B phase. Suppose the two current coils, that is A current coil and current coil B, which is connected in series with the phase R and phase B, and the two pressure coil or two voltage coil are connected to each other. Means this will be short circuited and this will be connected to the third phase. This will be connected to the third phase of the load. This is the total connection of your polyphase wattmeter, and this is your scale. This is your scale, and this is your spring control system, and having a one pointer. This will be shows the reading after the connection. Suppose we will give the supply to the three-phase load, then the power will be flowing through the circuit. This power, three-phase power, will be measured by this wattmeter, and this will be shown by the pointer on the scale. This measured power, which will be shown on the scale by using pointer. This is your polyphase wattmeter. Means in that video we have studied the low power factor wattmeter and polyphase wattmeter. Okay, thank you.